Hi, I'm Atul and I'm an online maths and science tutor based in London right now.
Hi, I'm Paul and I'm a chemistry tutor based in Burnley, Lancashire right now. So today we're going to have a look at identifying the charge of atoms and ions using a maths concept really called zero pairs. And we're going to be doing that by looking at building atomic structures and then having a look at ionic structures and seeing how if their charges are balanced or imbalanced, and if they're imbalanced, working out the actual charge. So first of all, we're going to have a look at a lithium atom. And here we've got lithium with a mass number of 7 and atomic number or proton number of 3. So I wondered, Atul, could you build the nucleus, first of all, for our lithium atom?
Sure, so we got 3 protons, and because there's a mass of 7, 7 minus 3, 4 neutrons. Get the 1 proton, 2, 3, get 4 neutrons. I'll just arrange them like this.
Excellent. So we can see there that we have 3 protons, which are positive, and 4 neutrons, which are neutral, like their name suggests. So our nucleus has an overall positive charge, 3 positive charge. So then could we have a look at the electron structure for lithium?
Yeah. Just going to build a shell, an empty shell to start off with. These are my 2 electrons. Of course, I need a third one. I've already filled up the first shell with 2. No more space left there. So, get a second shell. Make it a little bit bigger. And there's our electron there.
Excellent. So we can see we've got an electron structure of 2, 1. So I wonder now if you could show us, using 0 pairs, the charge on a lithium atom.
Yeah. So 0 pairs, as we discussed in the last video, are positives and negatives. So I'm just going to replicate what's happening here on this side, but in terms of charge. So got a proton and an electron. In terms of charge, the amount of charge a proton holds is exactly the same as an amount of charge an electron holds. So to make that clear, I'm going to make the physical sizes, but we're talking about charge purely here, not the actual physical sizes. I'll make them about the same size. In reality, an electron is a lot smaller than a proton or a neutron, and this is obviously not to scale. What I can do is slightly make the nucleus smaller. So 1 proton, 1 electron. There's actually 3 protons and 3 electrons, so I will so that's 3 protons and 3 electrons in terms of charge. And we know from 0 pairs that, electrically speaking, 3 protons and 3 electrons make a 3 0 pairs, and the net being that you end up with an overall charge of 0, so the lithium atom.
Excellent. So we can see there that a lithium atom and all atoms in the periodic table are neutral because they have a balance of protons and electrons in terms of charge. And as you said, they're not in terms of mass, because an electron is about 2,000 times smaller than the mass of a proton or neutron. So I wondered now if we could look at a lithium ion.
Yeah. Okay, so I'll just make a copy of this. And a lithium ion is formed in order to achieve a full outer shell. So in order to achieve a full outer shell, you'd have to lose an electron from this first shell. So I'm actually going to get rid of that, the process of forming an ion. That means I must get rid of the electron on this representation as well. Now this kind of zero looking thing is no longer true. I must adjust that so that now we've got 2 zero pairs and an extra positive charge. So we've got a surplus of positive. So I would have to call this Li plus, and hence the convention and the symbolism.
Excellent. So we can see, and in the electron structure and in the zero pair structure, we have there that we have one more proton than electrons, and therefore we have an overall one positive charge. And that would be the same result for all the elements in group 1 of the periodic table, because they all want to lose an electron to gain a full outer shell. Okay, could we now have a look at another atom? Let's have a look at fluorine atom.
Great. So you want me to build the nucleus again, presumably? Yeah.
Yes, the nucleus and then the electron structure. Yes.
Okay, so this is a bigger. There's more going on here. Nine protons and 10 neutrons. So I'll get the 9 protons first. And 10 neutrons. I believe that's 10. Yeah. And I'll build my little nucleus around there. It's a larger nucleus, so I'm gonna just make it smaller. Okay, that's the nucleus.
Great. So we can see there that because neutrons are neutral, and we have 9 protons, that our nucleus will have an overall positive 9 charge. So could you now have a look at the electron shells and the electron structure?
Yeah. So I'll make a first shell. The first shell can accommodate 2 electrons. So that's the first shell full. We're going for 9 electrons. So 7 more. I believe that's the 9 electrons.
It is. So there we have an electron structure of 2, 7. So again, could you use 0 pairs now to show the overall charge on a fluorine atom?
Yeah. So let's move this a little bit out of the way. So we've got 9 protons and 9 electrons. Make the electron the same size, roughly speaking. So 0 pair. 9 protons, 9 electrons. So there's 9 0 pairs. Four, 8, and let's go for 9. Put that a little separate. And electrically neutral because they're all 0 pairs. So I'll just make a fluorine.
Excellent. So we can see in the atomic structure, we've got 9 protons, 9 electrons, but we can see far more clearly with the 0 pairs that we've got 9 0 pairs, and therefore an overall charge for this fluorine atom of 0. So, as we did for lithium, could we now have a look at a fluorine ion?
Of course, I'll make a copy of this. And here it is. So this time, in order to achieve a full outer shell, we do need to have 1 extra electron. So I'm going to add an electron. I use the word add. That literally means mathematically as well, to actually, in terms of the charges, to add 1 more electron. So I will just take this one here, make a copy, and there's 1 more electron there. It's still the same number of 0 pairs, and the added electron has added 1 more negative charge unit. So I will follow that and add that on here, F minus for fluorine minus. So to compare, nothing, 0 paired, 9 and 9, 10, 10, 9, so F minus.
Excellent. So we can see in the electronic structure that we have 10 electrons and 9 protons, but more clearly with the 0 pairs, we can see we've got 9 0 pairs giving an overall charge of 0, but then 1 extra electron gives an overall charge of -1.
Fantastic, and we'll continue this with a whole bunch of other ions and show how the electronic structure is correlated to the 0 pairs and the balance and imbalance of those 0 pairs. Brilliant. Look forward to those next ones.
Great. See you next time, Atul. Thank you.